Okay, example 4, find the partial fraction decomposition of this. Now notice that x squared plus x plus 1 squared, it's a quadratic trinomial. I'm thinking maybe it factors. If you want to see if something factors, it's real simple. You just do your b squared minus 4ac, your discriminant of the quadratic formula. If that comes out to a perfect square, it's going to be factorable. If it comes out to a negative number, it's imaginary. If it comes out to 0 is a perfect square, so it'll still be factorable. But you're looking for this to come out to a perfect square if you're looking to factor over the set of integers, basically, or even rational numbers. So if I do b squared, it'll be 1 minus 4 times 1 times 1. That makes negative 3. Negative number, not factorable, so we can't factor this. So that's going to be the denominator of this problem. But again, that's just a simple test to see if something can be factored, if it's quadratic. So this has the same structure as example 2 did yesterday, in that we have something that doesn't factor into a power. So when I write 4x cubed plus 5x squared plus 7x minus 1 all over x squared plus x plus 1, the quantity squared, and I structure my decomposition, I'm going to have x squared plus x plus 1 to the first power and x squared plus x plus 1 to the second power. So again, whatever power this is, I have to count for every power of that, starting with 1 working its way up. Each of my factors in this structure is quadratic, so the top part has to be 1 less power, which would be linear. So I'm going to put ax plus b on top of this one. I'm going to put cx plus d on top of this one. Neither one of my denominators are linear, so that cover-up method will not work at all on this problem. So we have to go with what we did yesterday. No shortcuts on this one. And what I got to multiply by is the least common denominator, which is just x squared plus x plus 1 squared. So when I multiply the first fraction times x squared plus x plus 1 squared, both the denominators cancel, so we're going to get just the numerator 4x cubed plus 5x squared plus 7x minus 1. When I multiply ax plus b over x squared plus x plus 1 times x squared plus x plus 1 squared, one of those cancels out, leaving me with the top, which is ax plus b, times one of these, which is x squared plus x plus 1. And when I multiply this times this, those cancel completely, leaving me just with cx plus d. So again, we create the structure like we did yesterday, and our job again is to simplify everything as much as possible to compare powers of x together. So 4x cubed plus 5x squared plus 7x minus 1 stays over here. If I multiply ax times all these things, I'm going to get ax cubed plus ax squared plus ax. Multiply positive b times everything, I'm going to get plus bx squared plus bx plus b. And I still have plus cx plus d. And again, if I start comparing things, this is 4x cubed, this is ax cubed, there's no other x cubes, right? This is 5x squared, this is ax squared, this is bx squared. There's no other x squareds. This is 7x, this is ax, this is bx, this is cx. And finally, this is minus 1, this is b, and this is d. Equal signs right here. Over there so you can see it. So comparing left to right, obviously a is equal to 4, right? There's only one x cubed term. It's supposed to be 4x cubed, so a has to be 4 to make it 4x cubed. No way around that. Looking at the red ones, I can see obviously that a plus b has to equal 5, right? Ax squared and bx squared, the 2x squared objects have to add up to 5x squared. A and b have to add up to 5. We just figured out a is equal to 4, so that means 4 plus b is equal to 5, which means b therefore has to equal 1. Moving on to my next fact, I can see that ax, bx, and cx are making 7x, so I know that a plus b plus c has to equal 7. But we know that a is equal to 4, b is equal to 1, and c is what we don't know yet. 4 plus 1 is 5, move it across, we're going to get c is equal to 2. And finally, I can see that b plus d has to equal negative 1. constant matches the constant. B is equal to 1, so D would equal -2. So even when you get a lot of unknowns, doesn't necessarily mean it's going to be a difficult system of equations to solve. Quite often this happens where you just have a single object that matches a single object. Those are pretty easy to figure out. Okay, sometimes that doesn't happen, but sometimes you have to do a system of equations. But in this case we had 4 unknowns, made 4 equations, but each equation is pretty simple to solve based on our first fact leading to the next fact and so on. So all that's left to do then is to write our answer. There's the structure of our answer right there. We're going to simply replace A, B, C, and D with their values. So I'm going to get 4x plus 1. That's going to be over x squared plus x plus 1 to the first. And plus cx plus d is going to be 2x minus 2. And that goes over x squared plus x plus 1 to the second. And there's the breakdown of the given